Welcome back to my YouTube channel in which I have created playlist of data science covering the basic and advanced concepts. Now my next topic is clustering. So let's discuss what is clustering. Clustering is one of the most important techniques in unsupervised learning where the goal is to organize data into groups that exhibit similar characteristics. It helps reveal patterns and structures in datasets without any prior knowledge of labels or categories. Essentially, clustering algorithms try to partition data based on inherent similarities or distances between data points. Now let's discuss what are the key objectives of clustering. First, to group similar data points. The primary aim of clustering is to identify data points that are similar and group them together. Second is find hidden patterns. It helps identify underlying structures, trends, or patterns within a dataset which will not be immediately obvious. Third is data summarization. Clustering can be used to reduce complexity of the dataset by summarizing the data into a smaller number of groups or clusters. Last, outlier detection. Clustering also helps in identifying outliers, which may be useful for anomaly detection. Now let's discuss what the types of clustering. First, partitioning clustering. The data is divided into a predefined number of clusters. The most popular type of partitioning clustering is K-mean. Second is hierarchical clustering. This method produces a hierarchy of clusters that can be presented as a tree, that is dendrogram. It can be agglomerative, that is bottom approach, or divisive, that is top down approach. Third is density based clustering. This type of clustering relies on the density of database base points in the feature of space. Algorithms like dbScan are used for detecting clusters of arbitrary shapes and outliers. Now let's discuss what are the popular clustering algorithms. First is k-mean clustering. How it works: the user specifies the number of clusters k. The algorithm randomly initializes k centroids and assigns each data points to the closest centroid. The centroids are recalculated based on the mean of the assigned points, and the process repeats until the centroids no longer change. Now let's discuss what are the advantages of k-mean clustering. First, it is simple and easy to understand. Second, it scales well with two large datasets. Now, here are some of the disadvantages of this clustering. Now, let's discuss them one by one. First, it is sensitive to initial choice of centroids. Second, it requires a number of clusters to be specified beforehand. Third, it assumes spherical clusters with equal size and densities. Second is hierarchical clustering. Now, let's discuss how it works. Agglomerative. Bottom up starts with each data points as its own cluster and progressively merges the closest clusters. Second, divisive, that is top down. It starts with all points in one cluster and recursively splits them. Now let's discuss what are the advantages. First, it does not require specifying the number of clusters upfront. It produces a dendrogram which can help in choosing the optimal number of clusters because it represents data in the form of tree. Now let's discuss what are the disadvantages. First, it's computationally expensive, especially for large data sets. Now let's discuss what are the applications of clustering. First, customer segmentation. Businesses use clustering to group customers based on purchasing behavior, enabling targeted marketing and personalized services. Second, image segmentation. In computer vision, clustering is used to segment an image into distinct regions based on pixel similarity, often to simplify or classify visual information. Third is anomaly detection. Outliers or anomalies in a dataset can be detected by identifying points that do not belong to any cluster. Next is document clustering. In natural language processing, clustering is used to group similar documents together, enabling topic modeling, recommendation systems, organizing large datasets. Next is biology. Clustering used in genomics is used to group genes, organisms that exhibit similar characteristics, often based on gene expression data. Last, recommender system. By clustering users' products, a system can make recommendations by analyzing which cluster a particular user or items belongs to. Now let's move to the practical part. Here I have provided the code to demonstrate clustering that happens in data science using Python. First, import NumPy uh, package with the alias name as NumPy. Then import matplotlib package with alias name as PLT. Then import k-mean library to perform k-mean clustering and make blobs to read or generate 2D data. Then by using macblobs function or library, we will generate 2D data in which we are storing the result in xy coordinates. Then we will apply k-mean clustering by using k-means function in which we are initializing the number of cluster centroids with 3 number and then assigning the data or result in key mean variable. Then we will uh, get the cluster sentence labels with the help of k-mean.cluster center, k-mean.labels, in which we are showing result in centers labels variables. Then we will visualize the clusters with the help of plot.figure function, and then we will plot the data points with the help of scatter function, in which we are passing x coordinates, and then we will plot the centroids of the clusters with the help of scatter function again, in which we will provide the centers which we gonna choose. And then we will add labels and titles with the help of x label, y label, title function, legend function. At last, we will show the plot with the help of show function. So this was all about clustering. I hope you enjoyed my session. Thank you for listening me patiently.